Good day. Let's look at the last example on a question for a translated parabola. For this question, they are asking us to prove this equation, whether it is a parabola. So what you're supposed to do is you need to use the completing of square to prove this particular function given to you. So writing a question, we have 4x squared plus 8x plus 5 equal to y. Whenever you are completing a square, you need to make sure that the highest power of the x, which is the x squared, has the coefficient to be 1. In this case, the coefficient is 4. So you need to make sure you divide through all the terms by the coefficient of the highest power, so as the coefficient of the highest power becomes 1. So when you simplify, you get x squared plus 2x plus 5 over 4 equal to y over 4. You take the constants here to the right hand side. You have x squared plus 2x equal to y over 4 minus 5 over 4. Then the second term of the x will help us to complete the square. You need to find half of the second term of the x. Then the result that you're going to get, you add a squared to the both sides of the equation. This is going to be x squared plus 2x plus 1 squared equal to y over 4 minus 5 over 4 plus 1 squared. So the half of the two is 1, and we take a squared to the both sides of the equation. Now, the left-hand side squared is now complete. So we need to write this as x plus 1 all squared equal to y over 4 minus 5 over 4 plus 1. 1 squared is 1. And you need to use calculator to find the value for the constants that we have there. So we have x plus 1 all squared equal to y over 4. Then when you use the calculator to find the value of this, you're going to get negative 1 over 4. Then we complete our proof. This will give us, factor this out, you're going to get 1 over 4 out, y minus 1. And this has given you an orientation of a parabola. So you end this as required. So you can go further to sketch this parabola by finding the vertex, the directrix, and the focus. So you use this strategy, completing the square, to prove whether the given equation is indeed a parabola. And it must look as one of the orientations of the parabola that we have discussed, whether it is in the translated form or when the parabola is at the origin. Thank you very much for watching. I hope you can use all these examples that we have talked about to answer your own questions. See you in our next video.